Hey guys, welcome back. In this set of videos, we're going to be talking about common logs and natural logs. In this video, we are going to be talking about the common log, which is base 10. So in math, there are a couple bases that show up a lot more often than all of the other bases. And so we've come up with, math has come up with some useful shorthand for those. So base 10 is a really common base. And so we will abbreviate log base 10 of A as log of A. So anytime you see log written without a base indicated, that means that we are dealing with a base of 10 and it is implied. So log of A has an implied base of 10 and it is the common log. So one big reason that these come up is our calculator has come a long way over the past, but until recently, until like our modern calculators, the TIs, we were not able to do logs with bases other than 10 or the natural log on our calculator. So here's my calculator. And I am going to use my calculator to approximate these. And before I approximate these, I want to kind of think about what I expect these values to be. So I'm going to write down a couple logs that I know. I know log base 10 of 1 is 0. I know log base 10 of 10 is 1. I know log base 10 of 100 is 2. Okay, so these are a couple logs I know. So 5 is somewhere between 1 and 10, so I'm expecting this number to be a decimal between 0 and 1. So on my calculator, you'll see that there is a log button. That log button is the common log. So this log of 5 is really asking what is log base 10 of 5. And my calculator just has the log button. So when I hit log of 5, it gives me 0.69897, which is between 0 and 1, so I feel pretty good about that. But I am going to hit second log to get 10 raised to an exponent. It's just a shorthand. You could also type 10 raised to an exponent, 0.69897, and I should get just about 5. So 10 raised to the 0.69897 is about 5. Okay, so log of 0.3. I expect this to be smaller than 0. I expect this to be a negative number. So I'm going to hit that log button, 0.3, and I get negative 0.5228. So this is really saying 10 raised to the negative 0.5228 should be equal or just about equal to 0.3. So 10 raised to the, I'm just going to pull that value, gives me 0.3. So log of 7, this is 10 raised to what exponent is approximately equal to 7? So 7 is between 1 and 10, so I think this is going to be somewhere between 0 and 1. It's actually between 5 and 10, so it should be bigger than this number and smaller than 1. So log of 7 gives me 0.8451. So 10 raised to the 0.845098 gives me just about 7. So that's how I'm going to go about using my calculator to find these. I want to go through a couple problems here, or this kind of table that's a little bit helpful. So you'll notice that these are all the common log. They have no base indicated, which means they have an implied base of 10. So log of x equals y. This is the same thing as log base 10 of x is equal to y. If there is no base, you want to be thinking about the implied base. For now, as you're just getting used to it, you can write the 10 in, but as we move forward, you're going to want to move away from that just for convenience. So I can rewrite this as 10 to the y is equal to x. So log of 1. This is log base 10 of 1. That is 10 to what exponent is equal to 1? And the answer to that is 0. So log of 10. This is just like saying log base 10 of 10 is equal to what exponent? So this is 10 to what exponent is equal to 10? And the answer to that is 1. Log of 10 to the m. This is log base 10 of 10 raised to the m is equal to what exponent? 10 raised to what exponent is equal to 10 to the m? That is m. So we want to have all of these in mind moving forward to make our life a little bit easier as we work with common logs.